In this video, we will see what is PMF CDF PDF of discrete random variable. So, PMF is probability mass function, CDF is cumulative distribution function, and PDF is probability density function. And what is discrete random variable? Discrete random variable is a random variable which takes discrete values. Now, what is random variable? Random variable maps the outcome of the random experiment to the real numbers. So let us define PMF. In case of the continuous, PMF is not defined. PMF is defined for the discrete case only. So PMF is probability at one sample point or probability at particular sample value. So it is the probability at x equal to xi. So notation is px xi. X is random variable, xi is value taken by the random variable. It is probability x equal to xi. Let us define PDF. PDF is probability density function. It is represented as small f subscript capital X xi. Capital X is random variable and xi is values taken by the random variable. So fxxi is nothing but the summation as the discrete case is there, so summation you need. So fxxi is pxxi, that is PMF, and delta x minus xi. Delta is a continuous impulse function. So this is the formula for the PDF. CDF is the notation is fxxi. So CDF is obtained by PDF by integrating the PDF. So minus infinity to x, fx xi dx is the PDF or the CDF. So we know that PDF we have just now seen. It is the formula for the PDF. So integration and summation are interchangeable. So let us take summation and this part outside, and integration minus infinity to x delta x minus xi dx. So this integration of the impulse function is nothing but the unit step function. So we can write it as u of x minus xi. So you got PDF formula, CDF formula fxxi is equal to this one, summation pxxi u of x minus xi. So, so from here we can see that CDF contains step changes or the staircase, has the staircase form in case of the discrete random variable. So let us understand these formulas with one example. Let us take one random experiment of tossing 3 coins simultaneously. So the sample space contains these values. Either you will get all t, or you will get 2 t's and 1 head. Likewise, you will get the 8 combinations. So what is random variable defined? You have to count the number of heads. So x is equal to, here the 0, here head is 1, and here head is 1. Likewise, you can count the number of heads in this sample. You will get the random variable like this. So let us plot the PMF. So random variable values are 0, 1, 2, 3. So you have to find the probability at 0, 1, 2 and 3. So pxxi is the PMF. Px0, that means xi is equal to 0, is equal to probability x equal to 0. Now in this 0 is 1, so 1 by 8. So px1, probability x equal to 1. 1s are 3, so 3 by 8. Total are 8. Px2 is equal to 3 by 8 only. Px3 is 1 by 8. 3 is 1 only. So let us plot this graph. So pxxi and xi is plotted. Xi means either 0, 1, 2, 3. So the values are written 0, xi is 0, then probability is 1 by 8, or PMF is 1 by 8. PMF is again the probability. If xi is equal to 1, PMF is 3 by 8, 2, PMF is 3 by 8, 3, PMF is 1 by 8. So why we are doing all this? PMF, CDF, PDF are again nothing but the probabilities are, and these are different plots of the probabilities. So let us find so our intention is to find the probabilities with these graphs. So let us see how to find the probability at a point in case of the PMF. If you want to find the probability at x equal to 2.5, so at x equal to 2.5, suppose 2.5 is here. There is no discrete impulse is there, that's why probability is equal to 0. If there is impulse at that point, then you will get the probability in case of the PMF. Suppose you have to find the PMF in the range is between 1.1 to 2.2. So in this range, suppose 1.1 is here and 2.2 is here, so in this range there is one discrete impulse, so the probability is equal to 3 by 8. So the PMF contains the probabilities, PMF contains the discrete impulses, and if you want to find the probability at a point, there should be discrete impulse, and if you want to find the probability between a range, then in that range discrete impulse should come, then only you will get the probability. Let us see the formula for the PDF. PDF formula, as we have already seen, that PDF formula is summation PMF into discrete impulse versus delta x minus xi. Let us expand this for our case. In our case, the I values are 1 2 0 1 2 3. So I values are 4. So suppose px xi is equal to 0, then here xi is 0, then again xi is equal to 1. Here summation is over xi, so xi is equal to 1, then it is x delta x minus 1 px2 xi is equal to 2. Here 2 is there, 3 is there, then delta x minus 3. So px0 is equal to 1 by 8, already we have seen the PMF at 0 is equal to 1 by 8. At 1 it is 3 by 8, at 2 it is 3 by 8, and at 3 it is 1 by 8. Here is the graph in this one. So you got the fxxi form derivation or fxi form like this in our case in this experiment. So if you plot this, you will get like this. So at 0 1 by 8 is there, at 1 3 by 8 is there, 2 3 by 8 is there, and 3 1 by 8 is there. Here I have shown the arrow which indicates that at this point there is a continuous impulse function. Here continuous impulse function, here also continuous impulse function. That means PDF contains continuous impulse function, while the PMF contains the discrete impulse function. That's why here the dots are shown. So let us again, the purpose of plotting this is to see the probabilities. So let us see what is the probability at x equal to 1. Probability at x equal to 1 is equal to 1 minus to 1 plus fxx dx. Probability is calculated by integrating the PDF graph. So between 1 minus to 1 minus is somewhere here and 1 plus is here. So it contains the impulse continuous impulse function, and we know that with the amplitude 3 by 8, we know that integration of the continuous impulse function delta x is equal to 1 minus infinity to infinity. That means very delta x dx. Delta x has continuous impulse function has the property that its width is very small and height is very high or infinite. That's why area under continuous impulse function is equal to 1. So this area becomes the 1 if you put the value. Here you are going to put the value of fxxi, which is equal to 1 by sorry x 3 by 8 delta x integration 1 minus to 1 plus dx. Now integration 1 minus to 1 plus delta x dx is equal to 1. So you will get the value 3 by 8. So in short we can say that if at that point there is a continuous impulse function, then only you will get the probability. Let us see the probability between the range. So let us see 1.1 to 2.2. Here also there is a continuous impulse at 2, so you will get the probability equal to 3 by 8. Again the funda is same. So here the value is 0, here value is 0, but at 2 you will get the integration equal to 1 because there is a continuous impulse function. So you will get the amplitude is 3 by 8, so you will get the value 3 by 8. If you find the probability at 2.5, for example 2.5, you will find the probability at 2.5. Then here there is no, at 2.5 again you have to take the integration of the fxx function, but as you see that there is no continuous impulse function, or the amplitude is equal to 0, so you will get the probability equal to 0. So probability at x equal to 2.5 is equal to 0, because at that point there is no value of the fxx. So we can say that if PDF graph is given, if at that point there is a continuous impulse, then only you will get the probability, or in that range if there is a continuous impulse, then only we will get the probability. Let us see CDF. CDF formula is, you know that instead of delta you will get here unit step. Other things are same, so 1 by 8 ux, 3 by 8 u of x minus n, 3 by 8 u of x minus 2, and 1 by 8 u of x minus 3, because it is summation of PMF into unit step sequence. So at 0 the amplitude is 1 by 8, then at 1 it is 3 by 8, at 1 it is 3 by 8, then at 2 again 3 by 8 rises there, at 3 1 by 8 rises there, and final value of the fxxi CDF is always 1. So if you add here, if you say see here, it is 1 by 8, 1 by 8 plus 3 by 8 it is 4 by 8, 3 by 8 plus 3 by 8 plus 1 by 8 it is 7 by 8, finally it is 1. If you add all this, 1 by 8 3 by 8 3 by 8 1 by 8 is equal to 1. So let us see how to find the probabilities if CDF graph is given. If probability of x equal to 1, x equal to 1, there is a, if there is a step change, then only you will get the probability. Here the step change is there, the of the amplitude 3 by 8, so the value probability x equal to 1 is equal to 3 by 8. Otherwise you can find f of x 1 plus minus f of x 1 minus. So that is the difference between 1 plus and 1 minus. 1 plus is 3 by 8 and 1 minus is 1 by 8. Sorry, 1 plus is 4 by 8, 1 minus is 1 by 8. So 4 by 8 minus 1 by 8 is 3 by 8. Otherwise you see, if there is a step change, you will get, write down that step change, you will get the probability. At x, let us see what is the probability at x equal to 2.5. At 2.5, that means somewhere here there is no step change, continuous values are there, so the probability is equal to 0, because fx of 2.5 plus is equal to fx of 2.5 minus, which is equal, are same, that's why the probability is equal to 0. Let us see the probability at 1.1 to 2.2. So 1.1 is here somewhere and 2.2 is here somewhere. So in this range there is a step change of 3 by 8. So the value, so the answer is equal to 3 by 8. Otherwise you can do 7 by 8 minus 4 by 8, because at this point the CDF is 7 by 8, and at this point the CDF is 4 by 8. So 7 by 8 minus 4 by 8 is also 3 by 8. Otherwise see, if there is a step change in this range, there is a step change of 3 by 8, so the answer is 3 by 8. So we have seen that to find the probability in case of PMF, there should be the discrete impulse, then only you will find the probability. In case of the PDF, there should be continuous impulse, then only you will get the probability. And in case of the CDF, there should be the step change, then only you will get the probability in case of the, in the discrete case.